human body is about 2/3 fluid with mineral concentrations that are similar to oceans and seas. So essentially, we have internal seas. Two key minerals are sodium and potassium. And if we look at the concentration in the fluids in different parts of the body, they're actually quite different. Fluid inside the cell, or intracellular fluid, is very rich and high in potassium, while fluid outside of cells, called extracellular fluid, is very rich in sodium. Evolutionary biologists speculate that this is because of when they were developed. Cells are much older than tissues, and older oceans and seas were very rich in potassium. Whether that's accurate or not, we'll leave it up to those evolutionary biologists. But we know sodium and potassium are two key essential nutrients, and they have an impact on our blood pressure regulation, and especially when things go wrong when we have develop hypertension or high blood pressure. So let's take a look at these two minerals. Sodium is required for life, and the body doesn't easily store it, so we need to consume it regularly. Humans have a strong preference for salty foods. Research shows by at least 4 years of age, and maybe as early as 4 months of age, we already show that preference. Still, there's variation in the level of preference, and there's plasticity in that preference, which is just a fancy word that says that we can adjust to our preferences, meaning we can learn to like less, or sometimes we get adjusted to wanting more. Before we look at the numbers, I want to compare and contrast the words sodium and salt. So sodium is using the chemical element of Na, because the Latin word for it is natrium, is the element. Salt is actually sodium chloride. If we look at the amount of sodium in salt, so if we look at this table right here, we can see that in 1 teaspoon of salt, there's about 2,400 milligrams of sodium. But we have other sources of sodium, soda, baking powder, MSG, soy sauce, and you can see and compare the amount of sodium in 1 teaspoon of those foods. Still, over 90% of all the sodium in our diet comes from salt. So that's our one that we're going to focus in on. If we look at the sodium intake and compare it to our recommendations, these standards all give the same value. So the dietary guidelines, the daily value, and the UL all give the recommendation of keeping our sodium intake to less than 2,300 milligrams. So we can compare it to that value. You can see that females take in on average about 3,000 milligrams, and males on average, adult males, take in about 4,000 milligrams. So all of us are consuming too much sodium. Where do we get it? Sodium is actually found naturally in foods. So here, this graph here, we'll kind of compare where we get our sodium. And this is taking a look at the natural intake or natural value of sodium in foods. So that's this one right here. About 10 to 12% of all the sodium we consume actually comes naturally in food. Look over here at this graph, where we're comparing the amount of sodium found naturally in food. So look at milk and eggs. Here are the values that are in there. Animal foods will have a bit more sodium, and the fruits and vegetables are very, very low in the sodium values. Still, if we look at, this is a cup of milk, it's meeting in this green bar, it's about 5% of the daily values. So if that's the highest amount naturally in food, it's still a pretty small amount. Compare that here to the amount of sodium in a slice of pizza or in a double burger hamburger. We do have a little bit that we get in home. So here's these 5 and 6% values in this pie chart. Home cooking, so if you're making things from home, or that we salt shaker at the table, they add another about 10 to 11% again. Still, all of these together only represent about 25% of all the sodium consumed. Most of the sodium we consume is coming from processed foods. So if we look at where within those processed foods, this is a great graph put out by the dietary guidelines, and the biggest, almost half of all of our sodium that's coming from our processed foods is going to come from mixed dishes. So think about macaroni and cheese and the lasagna, the frozen foods that we have in our diet. So here's our primary source of sodium. It's going to be from processed foods. And you may think, well, we need less of it, let's take it out of processed foods. But there's pressure for the food industry to reduce the sodium in food. but that's harder than what it seems at first. Salt is a workhorse of a food additive. Not only does it add palatability, because we like our food to be a little saltier, but it also helps to stabilize the microbial activity associated with food safety. It helps with texture and color of foods. It limits ice crystals in formation in frozen foods. And it controls fermentation for fermented foods like sauerkraut, just to name a few. Add to this that the salt receptors, so you think, well, maybe we could have a salt substitute. But there are only 3 minerals that will trigger the salt on our receptor sites on our tongue, and that's sodium, lithium, and potassium. Lithium's toxic, and potassium triggers a bitter taste. So it's pretty tough sometimes to pull that sodium out of the food processing. Still, our taste for sodium is plastic. We can adjust it down, and food manufacturers have been able to pull some out. So we're going to take a look at that and how it relates to blood pressure. But before we do that, we need to take a look at potassium. Potassium is the other mineral that we're looking at. We look at potassium and sodium together because they have similar functions. They're both electrolytes and important with fluid balance, and also because they're both linked with hypertension. But potassium's at the opposite end of sodium. If we look at the recommendation, and we'll use the dietary guidelines again, it's recommended for both males and females that we consume more than 4,700 milligrams per day. But you can see here the average intake for females at about 2,300 milligrams, and guys a little bit better, but still well below the recommendation with an average intake of about 3,000 milligrams. We're well below what we should be taking in. If we look at our food sources, people think about the fruits and the vegetables, and they are good sources. A lot of people think about bananas and orange juice, and you can see that one banana and a cup of orange juice have about 400 to 500 milligrams. But many fruits and vegetables are good sources. Other foods, though, provide good sources of potassium as well. So we look at dairy foods, we've got nuts, we've got the meats, and less so with the grains and some other of the protein foods. So potassiums are in a wide variety of foods. If we don't have a lot of variety of foods, and we limit our fruits and vegetables, we're going to have low intake of potassium. But also what's important is with those processed foods. So with sodium, we saw that processed foods increase the sodium, but it isn't just that it increases sodium, it decreases the potassium. So go back to where we find our potassium. Higher values are found on the inside, the intracellular fluids. And when we process foods, we break up those cells and the potassium can get released. And if we pour off that fluid that went into processing, we'll pull potassium out. So this graph will show you the ratio, and the green here represents potassium and the pink represents sodium. So these are in the less processed foods, and we can look at the ratio of the amount of green to the pink. There's much more potassium than there is sodium. But when we process it, so all the ones on the bottom here are similar food groups, but processed, and we know that they've added sodium, but they've also lost the potassium. And that's, again, because they break up that cell and the potassium is released and lost. So now we have a situation where we have a lot of processed foods, too much sodium, not enough potassium, and this all sets us up to high levels of blood pressure.